Okay, so in today's video we're going to have a look at scatter graphs. Now there's a fair few bits to have a look at with scatter graphs, but as always grab a piece of paper, grab a pen, make some notes, and we're going to have a look at this question to start with. Now I will be uploading this document into the description, so if you do want to print these off and go from there, then feel free to do so. Otherwise you may just want to follow along on the screen, and I just think it depends on your personal preference there, but there will be a link in the description for you to download this so you can print it off and do all the drawings yourself. Now when it comes to scatter graphs, we've got a few things to have a look at. We need to have a look at plotting points, we need to have a look at drawing lines of best fit, we need to have a look at their correlations, which we'll talk about later, and also making estimates off that graph. So we're going to kickstart with these in parts, and there's quite a lot of words in scatter graph questions, so you'd always have to take that into account. You just need to read through these questions nice and carefully. And for the purpose of making this video a little bit shorter and a little bit easier to follow, I've gone for scatter graphs that are already plotted in the majority of those points for us, just to reduce the amount we actually have to do on screen and the time you have to watch me plotting points, as I thought that might be just a little bit boring to follow along with. So anyway, let's have a look at this question. We have the scatter graph shows the marks of 12 students' tests. And if we have a look at the graph, we can see we've got the science marks going up along the y-axis and the maths marks going along the x-axis. And it says here the table shows the marks of 2 more students. And we have 2 students here where we have someone that gets a maths mark of 12 and a science mark of 14. And then we have another student below there that gets a maths mark of 17 and a science mark of 20. Now in part A of the question, it then says show this information on the scatter graph. So we need to plot these 2 points. So we'll start with that yellow one there. We've got a maths mark of 12, which we can find down the bottom here of 12. And then we're going to go up to 14, and we're just going to follow what they already have, which is just putting a little X on that point there. For the one below them, we have a maths mark of 17, which is over here, and we're just going to go up to a science mark of 20. So following that line nice and carefully, you can always lay your ruler down if it helps, just to make it a little bit more accurate. And there we go, that's right at the top there. So there's our 2 points plotted, and that's part A completed. Now before we move on to the next part, there's something that I would advise you to do no matter what the question is asking on a scatter graph, and that is to draw your line of best fit. Do check to see if you have to plot any points first, as that might almost change your line of best fit slightly, but always draw a line of best fit. There is very rarely ever going to be a scatter graph question where you don't have to draw a line of best fit, so we're going to draw that in straight away. Now I don't have a ruler here to use on the screen, so I'm going to draw my line of best fit as best as I can. But just thinking about a line of best fit for the moment, a line of best fit is almost exactly as it sounds. It is a best fit going through the points. It's not an exact line that's necessarily even going to go through a single point. It's just going to go in the general direction of the points. Now what we could do is we could just go for it. Okay, so I'm just going to draw one in as I think would be relatively okay. So there we go, there's a line that's pretty much going through all the points. But when it comes to a line of best fit, everyone's is going to be ever so slightly different, or can be ever so slightly different. Because I could angle that ever so slightly more, let's think of how to phrase this. I could make the gradient slightly less or slightly more. What I mean by that is if we get rid of that one, we could have it going maybe like this. Or I could get rid of that again, I could have it going slightly higher up, maybe like this. Okay, and both of those lines, or all of those lines there, would be absolutely fine. Now the general rule is you want to have about the same points above and below the line. What I mean by that is these little crosses we have on the graph, we want about the same above the line as below the line. Now you don't have to rigidly stick to that, but we do want to get it in that sort of direction. Okay, so having a look at that, what have we got? We've got 1, 2, 3, 4, 5, 6 above the line, and 1, 2, 3, 4, 5, 6, 7 below the line, with a few of those being very, very close to the line. So that would be absolutely fine. You don't have to be too stressed about getting this line absolutely perfect. Obviously what we don't want to see though is a line going in the complete wrong direction in the complete other way. Okay, that obviously would be incorrect there. We do want to get it in the general direction that those points are going in. So we'll get rid of that one. There's our line of best fit. Now we can have a look at part B. And it says, what type of correlation does this scatter graph show? Now there are three types of correlation really. We have a positive correlation, we have a negative correlation, and our third one would be no correlation. And it's quite unlikely that you'd be asked a question on a no correlation scatter graph, as there's not really much that you can do with them. But we will primarily, and we will be focusing only on positive and negative correlations in this video. Now, this particular graph here we have is called a positive correlation. And if we imagine that we were sort of standing over here, it's almost like we have to walk uphill. Okay, so if we're standing over here, it's a bit of a silly analogy really. But if we are going from the y-axis and we are walking to the right along the x-axis, we'd have to walk upwards. And that right there is what we call a positive correlation, where the line is going upwards. If it's sloping the other way, like that little line I drew a second ago, that would be our negative correlation. And it would just kind of mean we would have to go downwards down the line, obviously using my little person analogy there. But let's get rid of that. So we have two options. Sloping upwards is going to be a positive correlation, and sloping downwards is a negative correlation. So in terms of this question, what type of correlation does it show? All we would have to say is positive. Okay, now this is just my personal preference, but I always like to stick that word correlation with it. Just in case it doesn't say the word correlation in the question, we would be wrong then just to put positive. If it just asked what sort of relationship it had, we would have to say positive correlation. So do get used to just including that word and just saying a positive correlation. I've not got much space there, so I'm not going to write it in. But had it have not said the word correlation, we'd have to make sure we write that in. So there's another key little point there. You don't want to be missing a mark for not writing that word. As it does say correlation, I'll just write the word positive. Now on to the last part. It says another student's mark in the maths test was 15. Estimate the science mark for the student. Now this is easy enough. All we need to do is find that information on the axes. So we have a maths test was 15. So if we go along the maths marks and we get 15 down here, all we're going to do, and do show this working out, we're going to get a ruler and we're just going to go up to our line of best fit. And this is where everybody's answer will slightly change depending on your line of best fit. And once we hit that line, we're going to go across and read that off the axis on the left. Now I've kind of sloped up a little bit there. And again, we do want to make this accurate as possible. I haven't got my ruler, but we'll do this with a ruler. There we go. And we get a mark of 17. Now depending on your line of best fit, it might have gone just over 17, so it might have been 17.2, it might have been 16.8. Whatever value you have, you read exactly what it is off the axes there. So for me, for my little estimate there, I'm going to go with 17. You don't have to necessarily round it to the nearest whole number if it does go over or just below. You're just going to read it exactly as it is on the axes. So for that one there will be a little range of values that people are allowed. So maybe it might range from 16.6 to 17.4, something like that. Okay, but obviously you will get the marks for this sort of question as long as you show this little dotted line and exactly how you got your answer. That will take into account that if your line of best fit was just slightly off, or you've done it a little bit in the wrong direction, that you did know what you were doing and you're using the correct method to find your estimate. So there we go, that's pretty much everything to do with the scatter graph. There is one more thing that we could have. We could actually have to plot maybe a point that doesn't fall within this general trend here. Let's say, for example, it said somebody got, I don't know, 18 marks on their maths test and 14 marks on the science test. And if we plot that point, that would be just here. Now that would be called an outlier. Okay, something that doesn't follow the general trend. And it might ask us about that. It might say, you know, why was this point out of the range, or give a reason why this point was over there. We might just have to give a little logical explanation, something along the lines of, and it can sound really sort of silly, but you might just say, well, perhaps that student had a bad day on the science mark, or perhaps their maths is just a lot better than their science. Anything that's logical that fits into a reason as to why this point might fall out of place would be absolutely fine. Obviously nothing silly there, but just thinking about something logical in real life. Likewise, we might be asked, to predict somebody's mark that got 21 on their maths mark. Now this graph obviously doesn't go up to 21, maybe 21 wouldn't exist on this test, maybe it only went up to 20. But let's say the test was out at 30 and it said to predict somebody's science mark that got, 25 on their maths mark. Now we would have to say in that situation that we couldn't, because it's outside of our data and it's outside of the graph, so we couldn't actually make that prediction because we don't have any data in that particular range. Now we're not going to focus too much on outliers because there really isn't much more to it than what I've just spoken about there, but it's just something to bear in mind, and one of the questions later will have a little bit of a mention of an outlier which we will have a look at. But there we go, that's pretty much everything to do with scatter graphs. Now what I'm going to do is I'm going to do one more question, and I'm going to do it a little bit faster, a little bit less explanation, and then a couple for you to have a go at. So let's have a look at our next question. Okay, so on to our next question. As I said, I'm going to go through this one quite a bit faster. Now it says the scatter graph shows the value of 7 Varley motor scooters. So we've got 7 scooters that are plotted on this graph that are the same scooter but just at different ages. It says another Varley motor scooter is 5 years old and has a value of £300. Show this on the scatter graph. So we're going to go along to 5 years, which is down here, up to 300, which isn't the easiest to see. Always check the scale here. It looks like every 2 squares is going up 100, as 500 is on our first thicker line there. So if we try and get 6 squares up, I'll try and do that as best as I can. And it's just there. There we go. Then it says to describe the relationship between the age and the value of the motor scooters. Now what I will say with this one here is this is a little bit different to the previous one. It says describe the relationship. So when it asks us to describe the relationship, here we're actually looking for a logical reasoning between what's on the axes. And if we have a look at what's on the axes, we have the value and we have the age in years. And it's essentially asking us not what the correlation is, but actually what is the relationship between these two things. And in regards to the scooter, we can see, and obviously if we look at the general trend of the points, which, as we should have done straight away, reminds us to draw our line of best fit, which I'm going to draw as best as I can, just like that. And as you can see, the line is sloping down. So although this has a negative correlation, if we're going to do this, which is to describe the relationship, we're going to actually write something in regards to the words on the axes. So what happens as the age goes up? Well, the value, as we can see, is going down. Something up here, which has an age of around about 1, has a value of 2000. But something down here with an age of around 5, or exactly 5 in this case, has a value less than 500. So as the age increases, the value goes down. Or we could say as the value goes down, the age increases, but it makes a little bit more sense for us to say as the age increases, the value goes down. And that would be our explanation. And we'll write that down here. As the age increases, the value goes down. Let's have a look. Let's write that all in. There we go. The value goes down. There we go. So let's have a look at our final part of this question. Okay, so on to the final part of this question. It says a Varley motor scooter is 4 years old. Estimate its value. So again, we're going to follow the same process as on the last question. We're going to go along to 4 years, which is just down here at the bottom, and we're going to go up to our line of best fit. So taking that up, there we go, and we're going to go as cross as accurately as we can. Let's have a look. So we said every 2 squares was around about 100. That's 4 little squares up from 500, so that would be £700. So our estimate there would be £700. And just as I said on the last question, there would be some room for people to have different answers there. Maybe it might range £100 either way, so ranging from £600 to £800. But again, as I said before, make sure you draw on these dotted lines. So the big change in this question, and what was a little bit different, was that part B, and it said describe the relationship. So do make sure you read the question carefully there. If it asks you to describe the correlation, then we can obviously say it's a positive or a negative correlation. But if it does say describe the relationship between the age and the value, then we're going to write that in words. We're going to say as the age increases, the value goes down. Or if we think about that last question, it would have been something along the lines of as the marks for the maths test went up, so did the marks for the science test. Okay, so there's a couple of little differences between these questions, but otherwise they're all generally sort of similar. We have to sort of plot a point, draw a line of best fit, describe a relationship or correlation, and then use our scatter graph to estimate a particular value that's given to us using that line of best fit. And as I mentioned as well, sometimes there is a little bit of a mention of an outlier or something along those lines, which we will meet in our final question. But enough of that. There is a couple of questions for you to have a go at. Let's have a look at our first one. Okay, so as I said before, there is going to be a link in the description so you can print this off and have a go. Otherwise, you may just want to kind of visualize on the screen exactly how you would approach this, or you may even want to just draw it out or draw a little sketch and sort of do it as best as you can. Completely up to you. I do think that these kind of ones, as they are already slightly plotted, you should be able to just sort of do them on the screen and just sort of imagine where you draw the line and imagine going up to the line and maybe using your finger on the screen to sort of make an estimate. But that would be completely up to you. But that is there if you do want to download that and print it off. But let's get started. So pause the video there, have a go at this question, and we'll go over the answer in a sec. Okay, so this question is around It says a cafe records the maximum temperature in degrees Celsius in Clacton and the number of hot chocolate drinks sold. Now let's just think logically here. We would imagine as the temperature goes up, we would probably drink a less hot chocolate, so we're more likely to drink a sort of colder drink. So just thinking logically about that and how it might relate to our scatter graph. It says on another day, the maximum temperature was 6 degrees and 35 hot chocolate drinks were sold. Show this information on the scatter graph. So let's go along to 6 degrees down the bottom there, and then up to 35, which again is between 30 and 40. So we're going to put that in as best as we can to make sure I'm on the right line there. And that is going to go just in the middle there. Now we've got that done, again, straight away, let's draw a line of best fit. And again, I'm going to just sort of place mine around about there. What have I got there? I've got about 4 above, 4 below, 1 on the line. That's about right. So there's our line of best fit. It now says in part B, describe the relationship between the maximum temperature and the number of hot chocolate drinks sold. So again, in this description, if we were asked about a correlation, this one here has got a negative correlation, but we're being asked to describe the relationship. So our description would be, as the temperature increases, the number of hot chocolate drinks sold goes down, which was our logical thought at the start. Or again, we might have phrased that the other way. We might say, as we sell less hot chocolate drinks, the temperature goes up. But it's more, logically, it's more about the fact that as the temperature goes up, we buy less drinks, so we sell less drinks in terms of this explanation. And there's our description. I'm not going to write that down, so there we go. And then part C here, we've got one day, the maximum temperature was 8 degrees Celsius, estimate how many hot chocolate drinks were sold. And again, we'll go along to the 8 degrees here. We'll draw our dotted line, obviously using a ruler. That is absolutely terrible by me there. Let's draw that in again. This is exactly why you use a ruler. I'll try and do it as best as I can. There we go, up to the line. Then we'll go across. There we go. And there we go, just about hit the side there. So on my line of best fit there, that is looking like it's around 24. So I'm going to make my estimate of 24 hot chocolates. But again, don't forget, if your line of best fit was slightly different, you would probably be allowed anywhere between 22 and 26. Although obviously the best way to do this is just to print it off and have a go. But somewhere around there is going to be fine. Okay, just looking at your line of best fit, you should be able to compare it to mine and see if it's going in the same sort of direction. There we go, there's our first question. Let's have a look at our last one to finish. Okay, so for our final question of this video, we're going to have a look at this one. Now it says here, Sally looks after a children's paddling pool in a park. Each day, Sally records the number of hours of sunshine and the number of children who use the paddling pool. And again, thinking about something logically here, we would imagine that as there's more sunshine, there's going to be more people in the pool. It tends to be that obviously as it's colder, when it is colder, we wouldn't necessarily want to go in an outdoor swimming pool. So just thinking about a bit of logic there. It says here, for part A, describe the correlation. Now, before I go on to do that, that means that we're not going to have to plot a point. Or maybe we'll have to plot a point, but it's not asked us to do so in part A. And before we want to have a look at correlation or anything, we want to draw that line of best fit, even though we've not been asked. So let's draw that in straight away, and there we go. I'm going to go for about that. I would actually probably maybe angle that slightly steeper, but there we go. I'm happy with how it looks at the moment. We've got 4 below and 5 above, so that's absolutely fine with me. So on to part A, it says describe the correlation. So here we go, as you can see, this time we've not been asked to describe the relationship, but we've been asked to describe the correlation. And for this one here, we have a positive correlation, it's sloping upwards. So let's just label that positive. And I'm going to write the word in this time, correlation. There we go, so we've got a positive correlation for this one. For part B, it says, one day there were 10 hours of sunshine, estimate how many children used the paddling pool. And this is obviously where we're going to use our line of best fit now. So for 10 hours, let's have a look, that's down the bottom there. We are going to want to bounce that 10 hours all the way up to our line of best fit. Let's have a look. There we go, and we'll go across from there as best I can. Have a quick look at the scale. It looks like every line there is one child. I think I've just slightly bounced that up a bit. I think it's more likely on that line just there, which is 41, 42, 43 or 44. I can't look at it perfectly there. I think it's around about 43. It may be just between 43 and 44. I think it's 43, so I'm going to go for 43. And there we go, that would be my estimate, 43. But again, as we've already mentioned, everyone's answer is going to be slightly different there. Maybe you might have a range of 41 to 45 or something like that, just depending on how how large the scale is there, but 43, 42, 44, anything like that is going to be absolutely fine on that question. Part C then, we've got on another day there were 6.5 hours of sunshine and 45 children used the pool. Show this information on the scatter graph and explain what may have happened on this day. Now let's have a look at this one. So if we plot this point, and in fact let's go with a different colour, we're going to plot this one. So 6.5 hours, obviously between 6 and 7 there, and it says that there were 45 children. Let's have a look. So that's going to be 6.5, 45, up here, right by our purple line there. Let's mark that point on quite clearly. Now that point there is clearly out of the way of the other points, so that's clearly an outlier. Okay, it doesn't fall within our normal trend, and that's why it's said here, explain what may have happened on this day. So again, and I'm not going to write an answer down for this one because there's so many things that we could write, but we need to think about a logical answer. Why might it be that there was 6.5 hours of sunshine on this day, but there was a larger amount of children in the pool? Now, potentially, you know, something along the lines of it might be a school holiday. Maybe there was a school holiday on this day, and although there wasn't as much sunshine, a lot of children ended up going in the pool. You know, any sort of logical reasoning along those sort of lines that show that you can sort of think outside the box. Obviously, we don't want to give a silly answer at this point and lose marks that way, but anything that's logical and makes sense. Maybe there was somebody that had a birthday party, something like that, okay? Anything that seems logical. So that would be an answer, okay? You'd write any of those down and just make sure that your answer, as I've said before, isn't a silly one, because you don't want to lose marks for coming up with a silly answer. You know, you just want to give something that's logical and sort of real life scenario. But there we go, that's scatter graphs. There's nothing really more to talk about on those. Going into the higher end of scatter graphs, you could have quite a nasty question that maybe asks you to calculate the gradient. But that's just calculating the gradient just like you do in normal coordinate geometry, and again obviously we've got the series on those that you can always refer back to. So that is the end of that on scatter graphs. Obviously don't forget to check out the rest of the series, looking at some of the other graphs like your box plots and all that sort of stuff, particularly if you're looking at the higher, or some of the other graphs if you are obviously doing the foundation paper. But this is one of those crossover topics that appears on both, so it's quite an important one to make sure that you are pretty comfortable with. But there we go, there's the end of the video. Hopefully you found that useful and helpful. If you did, please like, please comment, please subscribe, and I'll see you for the next one.